Going to do a summary of log today. So we need to know what is an index form. This is an index form. We can write it in log form by writing x the subject, x equal to log base a y. Okay. So we need to be able to convert from one form to the other, log form back into index form. And some of these letters have names. So the x are called the index, and the a is called the base. Same as this a here. Okay, write it down. Alright, next one, we need to know some of the special values of the log. Log 1 is 0. Log base a is 1. ln 1 is 0. ln e is 1. Okay. And then once we do that, we're going to look at some log laws. So when you add two logs together with the same base, if the base has to be the same, become log base a. Oops. Log base a x times y. And then when we times inside log, you can split it into two parts, become log base a x plus log base a y. When you subtract two logs, it becomes division, so it becomes x over y. And then when log of a division is become minus. So you need to interpret both laws, all these laws in both ways, both in combining the two logs and splitting the two logs into two parts, both of which have applications. Next one is, if there's a power, you can bring it down. This is very useful when we solve exponential equations, as well as differentiating certain types of functions, and log base a x. Or sometimes you may want to bring it up for other purposes, log base a x power of n. And there's also change of base law. Change of base law, that's on the formula sheet. Yep. 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 Okay. And then there's a change of base law, so you can change it to base b x over log base b a. Okay, so you can change it to any base. That's on the formula sheet. Okay, so you can change the base from a to b by writing it as a fraction. So I'll write it down. This is on reference sheet. Okay, we should also be familiar with some of the graphs and draw some basic ones, like the exponential graph. Let's draw the exponential graph. So it looks like this. 1 is about 2.7. Okay, that's an exponential graph with a horizontal asymptote. So this is y equal to e to the power of x. Note that it crosses the y-axis at 1. Has an asymptote on the x-axis. And you should note the domain range from the graph. The domain for an exponential is all real x. And the range is just positive value of y, excluding 0. We should also be familiar with the logarithmic graph, which I will do in purple. It has an x-intercept of 1, has a vertical asymptote instead of horizontal, and goes up like this. So we know ln e is 1, so e is about 2.7, so that's e, it's 1 here, right? So E1. Right, like that. So we'll see that the domain is x positive and the range is all real y. And later on in later topics, you will learn about inverse function. They are actually inverse of each other. They are inverse of each other. They are inverse of each other because they undo the other operations. You will see that it's a reflection about the line y equal to x. So y equal to x, they are a reflection of each other. Reflection. Alright, so these are the two graphs drawn. So make sure you remember its main features, that it has a vertical asymptote, has an x-intercept of 1. I think all log graphs have an x-intercept of 1 because log of 1 is always 0. Whereas the exponential graph always has a y-intercept of 1 because e to the power of any number to the power of 0 is always 1. Okay, after we do this, we're going to differentiate log. So we're going to write down some formulas. So the first one is derivative 1 over ln x is 1 over x. So if you differentiate log basis of a function, is f dash of x over fx. And to do the last one, you do the change of base law. You use change of base. Change of base. So what you do is you write it as derivative of ln fx over ln a. Right? So when you differentiate ln fx, it becomes f dash of x over fx. And then you just have an extra ln a at the bottom. So use change of base law when the base is not e. So you can see the main difference is between these two, they're the same, except that it has an extra ln a because the base is not e. Okay, so that's the derivative, that's the graph. Let's do a derivative. So this example where we have to use the log law to simplify the differentiation, particularly the one that involves square root. So to do that, you need to use the log law to write that as x plus 4 to the power half. And the log law permits us to bring that half down. That will make the differentiation easier, like this. So once you bring the half down, then you can differentiate it. Then you have to differentiate the square root. You can just differentiate ln x plus 4. So now you can write dy over dx. Dy over dx is half. That half just stays there, times by using this rule, 1 over x plus 4. Which becomes half, which become 1 over 2 bracket x plus 4. Okay, good. So we're done. So there's another 2 pages that follow. So one more page of summary. That okay, we'll go to the next page when you're finished. Okay, next page. Differentiation involving exponential. Okay, so differentiation. Let's look at the first one. Derivative of e to the power x is e to the power x, just itself. We learned from one of the exercise differentiating a base other than e. So there's an a. Just remember, just put ln a there. If you forgot, you can just use the change of base law. So there's a change of base law for exponential. Change of base for exponential. You just use this formula. F of x equal to e ln f of x. That will be useful. Okay. Alright, so you can use that to differentiate that, but if you memorize the formula, that will make it easier. And then we're going to continue. If you differentiate exponential of a function, it's f dash over e to the power fx, like this. And then if you differentiate with base a, it's the same formula, f dash of x, a to the power fx. You just have to remember to add an extra ln a in front, like we did with this one, okay? All right, complete the exponential. Have a try. All right, we'll continue. Okay, good. All right, so integrate exponential is exponential e to the power x plus c, and this one is a to the power x, but you just divide by ln a, extra ln a there. So differentiation in times by the ln a, integration you just do the reverse, you divide. This one you just do 1 over a, the coefficient of x, right? E to the power of ax plus b plus c. And if it's another base, you do the same thing. 1 over c, a to the power of cx plus d plus, maybe we have to use another constant d. And then you write that over ln a, extra ln a, like we did here. Okay, very similar. Okay, these are the formulas. So only on the reference sheet, only these two are given. This is given on the reference sheet, and this is given on the reference sheet. The other one you need to memorize. And then we have integrations. Integral 1 over x is ln x. Now integrate this is ln f of x plus c. Right? And this rule is x power n plus 1 over n plus 1 plus c. Okay, like that. Just remember there's a condition, n cannot be negative 1. And when it is negative 1, use this rule. Okay, when n is 1. Negative 1. Okay. And the same rule for the other one. So we're going to write this is ax plus b to the power of n plus 1 over a n plus 1 plus c. Okay. Again, there's an expectation n cannot be negative 1 as well. If it's negative 1, you probably have to use this rule as well. So you have to write it in the form of f dash over fx. All right, all of these are done. So we're going to apply this rule into 4 questions, and they may not use the same rule. They may use different rules. They all have a fraction, but as you can see, not all fraction and log, and not all fraction involve logarithms, and some fraction doesn't involve logarithms. So let's look at how this works. So we'll try the first question. The first one, you can see when there's a constant there, you can just bring it out, just write 1/5, and you can just do it normally. So this is just 1/5 bracket x cubed over 3 plus 7x plus c, right? So if it's a constant in the denominator, just bring it out, it becomes a normal. However, when it's an x squared, you can't bring it out when there's a pernumeral. So when there's a pernumeral, you have to split the fraction. So you split, so you get x cubed over x squared plus 3x over x squared plus 1 over x squared. Okay. Let's make it a bit bigger so I could write it a bit smaller. Okay, so that will become integral of x plus 3 over x plus x power negative 2 dx. Now note that I shouldn't write this as 3 to the power x power negative 1 because I can't use this rule, isn't it? I can't use this rule when the power is negative 1. So that's the case where you have to use ln. So the first one is x squared over 2, but the second one is 3 ln x, right? But the last one, this is not ln, this is just using the rule again, x to the power negative 1 over negative 1. Note the differences between this one, when the power is not negative 1, it's a fraction, you use the rule, you add the power 1, divide by the same power, but when the denominator is just x, it's just ln x. So you can just simplify it to be x squared over 2 plus 3 ln x minus 1 on x plus c. Okay, alright. All good, done. Right? Okay, let's try the next one, C. What should we do? What should we do? Or maybe we could do this first. Maybe we'll do this. So we'll get 5x minus 2 to the power negative 1. Again, check the criteria. If you write it like this, which look like this formula, but because n is not negative 1, you can't use this formula, isn't it? Right? This one over there, can't use. So you can't write it in this form. So what you need to do, you have to do the checking. You have to write. So when it's like this, you have to check whether it's log. Maybe it's this rule, f dash over fx. So you're going to write, this is your fx, 5x minus 2. And if you differentiate it, you get 5. So I need to have 5 on the top. So that means I need to take the 3 out. 1 over 5x minus 2 dx. And then what we do is, you're going to replace it with the 5. But because I added 5, I must divide by 5. So to keep it balanced. And now the integral is in the form of f dash over f. And the f dash over f is ln of the denominator. With the 3 over 5 in front, plus c. On the other hand, if you use the same rule for this, it doesn't work, because if you differentiate it, let's say if I make fx equal to 3x minus 4 squared, if I differentiate it, I get 2 3x minus 4 times 3, which you can't put an extra x on top, so you can't use the ln method. So in this case, you have to write it in index form. So the index form will be, so you write that as 5 bracket 3x minus 4 to the power negative 2. Okay? And then I'm allowed to use this rule that I wrote over here. This rule is allowed. Ax plus b. So I'm going to use this rule. So you write 5 bracket 3x minus 4 to the power negative 1 over negative 1. But remember to multiply by a. A is this number here, which is 3 times negative 1 plus c. So therefore you get 5 3x minus 4 to the power negative 1 over negative 3 plus c, like that. And then you can write it without negative indices, so you can write that as 5 over negative 3 bracket 3x minus 4 plus c, if needed. And now I've got a very difficult HSC question to go through, and then we can start the chapter review and challenge. Okay, so we're going to go to the next page. Alright, so this is from a 2002 exam, extension 1. It's question 6, so it's the second last question because the OHSC is question 1 to 7, no multiple choice, so this is the second last question. Okay, alright, so we're going to look at this question, which is related to what we do. Okay, so let's look at this. So the first question worth 2 marks is by considering the graph of this, show that this integral is between these two numbers. Let's draw a graph, see what that looks like. So we're going to draw a graph of 1 over x. Hopefully you remember this is a hyperbola. Right? This is y equal to 1 over x. Hyperbola. Like this. To draw a graph, and they say use the graph, by considering the graph of 1 over x, use the graph to show why the integral of 1 over x is between these two numbers. So we're going to illustrate the area underneath the graph. So 1 over x from n to n plus 1. So n is over here. Let's say this is your n, this is n plus 1, right? So this area, the shaded area, is represented by this integral from n to n plus 1, 1 over x dx. Alright, good. Now we have to show this area is in between these two numbers. Now how do we show it's in between these two numbers? To do that, you have to consider rectangles. So we're going to consider a rectangle below. Right? So we can draw a rectangle. And then we can consider a rectangle above. Okay? Therefore, the area in between them must be less than the purple rectangle, but must be greater than the red rectangle, which is a shorter one. And the question is, what's the area of these two? That will yield our result that we want. Alright, now finding the area of the rectangle is not hard. Let's work out the length and the width of the rectangle. Okay, let's work out maybe the width. So what's this length? 1, right? Because n and n plus 1, that's a length of 1. Okay, so the hard part is to work out the height. So let's work out the height of the rectangle. So to work out the height, you need to find the corner of this point. How do I find the corner of this point? We substitute n plus 1 into 1 over x. So this point is n plus 1, comma 1 over n plus 1, right? Because the equation of the graph is y equal to 1 over x. And on the other hand, to get the corner of this point, you substitute n into the equation, so it will be n comma 1 over n, which indicates to you this height is just 1 over n. Right, and the other height is 1 over n minus 1, 1 over n plus 1. So I could just summarize over here. So the height of this is 1 over n plus 1. The other one is 1 over n. Both has the length, both have width 1. Okay, so now we can find area for both. So therefore, the integral, the shaded area, is in between length times width, actually not equal, but less than this area, but bigger than area of the other bit. So therefore, we get 1 over n plus 1 is less than integral n plus 1 and dx over x less than 1 over n. Is your final answer. So you have to show here. So this is part 1. Okay, take a minute to digest. part 2. Let's write down what part 2 look like. In part 2, we have to show, deduce. So using part 1, when they use the word hence, you say basically means you have to use part 1 to show that this thing is less than e, less than 1 plus 1 over n plus 1. Alright, so how do we show this? Now, to show that, you have to use part 1. You have to use this rule. Okay? So what we're going to do is, let's take this rule down. We're going to start from what we know from part 1. So you say, from part 1, you can write 1 over n plus 1. It's in between integral n plus 1, 1 over x dx, less than 1 over n. Now the question is, where does the e come from? You see, there's n and n plus 1, but you have to create the e. To do that, you have to integrate this expression, because when you integrate this expression, you get ln x, which is really log base ex. So that's where the e comes from the log base ex, right? That e. So hopefully we can make the e appear like this, okay? So you can do the definite integral, which is between 1 over n plus 1, and become log base e n plus 1 minus log base e x, log base e n, like that. So now we have got, again, you can combine the log using the log law we discussed today, n plus 1, like this, minus you divide. Alright, that's what we got so far, isn't it? But we have to make the e appear. Not this one. Oops. Let's make it big. Okay, so we want to make e appear. So we got to this. The question was 3 marks, so maybe you only get 1 mark by getting to this stage. So the question is, how do I make it look like this? Yep. Oh, oops. Right. Okay, done. Alright. So we got this thing. So the question is, how do I convert this into this? That's the next hard question. So what we're going to do, now actually we can do something nice. So see that 1 plus 1 over n, we can make that appear by splitting the fraction into 2 parts, n over n plus 1 over n, right? Which become log base e 1 plus 1 over n. So this is a good progress. I could see certain things starts to appear, right? This thing starts to appear. So the question is, how do I get into this form? Okay, so we got the most of the parts that we want. We've got the 1 over 1 plus 1 over n. And the question is, how do I make it look like this? Now, there's extra space on the next page. Next page is blank. If you need it, you can go to the next page to continue to write the proof. Okay, so I'm going to plus this, and then we'll go back, and maybe I could copy some stuff. So maybe copy all of this. Oops, Control Z. Okay, so let me try to copy this over the next page. Okay, but I don't need everything, so I just have this on top and just delete this bit. Okay, and I just rub off this bit here. Okay, so that's what we got so far. We got this thing. We're going to continue. Alright, so what we do is, we're going to split into 2 parts. We're going to write this thing here. Okay, we're going to write this one here, and then write the other one there. Log base e, 1 plus 1 over n is less than 1 over n. So we're going to split the inequality into two parts. And then we're going to use the rule that we have. So the rule I'm going to point to you, the rule is, I'm going to write it in a different color pen. Remember this, e to the power of log base e fx becomes f of x. So what we're going to do is to get rid of the log. To get rid of the log, we have to exponentiate. So if we exponentiate both sides, so we're going to do e to the power of 1 over n plus 1 less than e to the power of log base e 1 plus 1 over n, right? So I'm just exponentiate. So this left side and the right side become the power of this base e. Now why do I do that? Because by using this rule, when you have exponentiate log base e, they cancel, isn't it? Sort of they cancel, just become f of x. That's what I want. I want to get rid of the log. Okay, so we got this, but the left side still remains to be the same, like this. Okay. Okay, so the question is, I need to make e appear now. It's getting very close, so we have to get rid of the power. How do I get rid of the power? We raise it to the power of n plus 1, because that will cancel, like that. So they multiply to become 1. So and then you get e to be less than 1 plus 1 over n plus 1. Which is the stuff on the top, isn't it? Right? Which is this bit. Where does the other bit come from? Come from here. That's why I'm doing in two separate cases. So do the same thing. See if you can work out. So use that to guide you to do this bit. It's exactly the same process, just slightly different. Okay, have a try. Give you a minute or so. So do the same thing with this. Exactly the same thing. Imitate what I did in here, apply it to this case. Okay, write it down. Okay, your first step is to exponentiate both sides. E to the power of log base e, 1 plus 1 on n is less than e to the power 1 over n. They get cancelled, you get 1 plus 1 on n, less than e to the power 1 on n. Raise both sides to the power of n. They get cancelled, so you get e is bigger than 1 plus 1 on n to the power n. So you got e is bigger than this, but e is less than that, and then you combine together. Oops, press the wrong. What is that? Okay, so we're going to I forget why one is make it a bit bigger. Okay, now what we're going to do is to combine the two. So basically, we've split into two parts, and then get it back, and then combine them together. Combine. So you put the e in the middle, in between 1 plus 1 on n, bigger than 1 plus 1 on n to the power of n. Done. Okay, so it can be a difficult question. Okay. Okay, good. Alright, any question? I'll need to make one more extra comment. Now, there's a rule in math, so e is actually can be found in another way. If you take the limit as n goes to infinity of this thing, it actually becomes e. You could try on a calculator. So say, for example, substitute n to be 100, right? So actually you can substitute n is 10, see what you get. So we're going to use a calculator. So let's do bracket 1 plus 1 over 10 close bracket to the power of 10, you get 2.59. So if you increase one extra 0, you get 2.7, right? Remember what E is. E is this number, 2.718. So if I increase more 0, that will become more accurate. 2.7, 2.1, yeah. But maybe a bit slow, so you have to get more zeros. And there you get. So as n goes to infinity, it does approach this number, isn't it? Right? Which is 2.18. Okay, good. So this rule is true. But you don't need to know this rule, but it's good to know. All right. What else I'm going to say? That's it. All right, good. So you will do the revision exercise today. And then try some past HSC question, which is also useful. Finish.